مساء الخير. Let us start chapter 13, decision analysis. In this chapter, we will consider together how a decision analysis help decision making to select a certain alternative among a set of alternatives. If you remember our first lecture in this class, we said that a decision is a function of decision alternatives and environmental conditions and state of nature. We will explain this topic into two videos. Video number 1 will concern with topic number 1. Video number 2 concern with topic number 2. Let us go. Decision analysis can be used to develop an optimal strategy when a decision maker is faced with several decision alternatives and an uncertain or risk-filled pattern of future events. So, decision analysis repeatedly proves its value in decision making. How? When a careful decision analysis has been conducted, uncertain future events make the final consequence uncertain. In some cases, the selected decision alternative may provide good or excellent results. The risk associated with any decision alternative is a direct result of the uncertainty associated with the final consequence. A good decision analysis includes risk analysis, where the decision maker is provided with probability information about favorable as well as unfavorable consequences that may happen. How we will go into this topic? This topic will be divided into 4 subtopics. Topic number 1, problem formulation. Topic number 2, decision analysis without probability or decision making without probabilities. Topic number 3, decision making with probabilities. And these 3 topics will be considered in this video. Topic number 4 will concern with decision analysis with sample information, while topic number 5 concern with risk profile and sensitivity analysis. According to our current situation, we will drop topic number 5, risk profile and sensitivity analysis, in spite of its essentiality for you in business. This means that in our course, we will consider only the first four topics. Topic number 1, 2, and 3 will be considered in this video, while topic number 4 will consider in the next video. Let us go to problem formulation. How we can formulate a decision problem. A decision problem is characterized by decision alternative, state of nature, and resulting payoffs. And this is what we mentioned in our first lesson in this class. We said that a decision is a function of decision alternative and state of nature and environmental condition. The combination between any decision alternative and any state of nature will lead to a certain payoff. The decision alternatives are the different possible strategies the decision maker can take. The state of nature refers to the future event or to environmental condition, which the decision maker cannot control. So we define it as follows. The state of nature refers to the future event not under the control of the decision maker. State of nature should be defined so that they are mutually exclusive and collectively exhaustive. Both of decision alternatives and state of nature will be formulated in a model called influence diagram. The influence diagram is a graphical representation of the relationship among the decision, the chance event, and the consequence. To draw this diagram, we will use the following symbols: squares or rectangles to represent decision nodes, circles or ovals to represent chance nodes, state of nature, diamond shape to represent consequence nodes, line or arcs or arrows to connect the nodes, showing the direction of the influence as follows. The rectangle represents the decision alternatives. Decision alternative number 1, small complex shop, decision alternative number 2, medium complex shop, large complex shop decision alternative number 3, environmental condition, demand, state of nature, strong or weak. The combination of D1 with S1 will lead to a certain amount of profit. The combination of D1 with S2 will lead to another amount of profit. The combination of D2 with S1 will lead to a certain amount of profit. D2 with S2, another amount of profit, and so on. So the profit is a consequence. The consequence will lead to the payoff. This payoff can be represented in tabular form called a payoff table. The consequences resulted from a specific combination of decision alternative and state of nature is a payoff. These payoffs can be represented numerically in a tabular form. This tabular form is a payoff table. Payoffs can be expressed in terms of profit, or in terms of cost, or in terms of time, or in terms of distance, or any other appropriate measure expressed in the decision problem. How we can make a decision analysis? How we can make decisions? We can make decisions either without probabilities or with probabilities. Let us start with the first one, decision making without probabilities. Decision making without probabilities, it means the decision maker has no information. He can use it to assess probabilities, to assess a certain type of likelihoods, to differentiate between different environmental conditions or different state of natures. In this situation, the decision maker will depend on his risk attitude and his talent toward risk. 3 commonly used criteria for the decision making will be used when probability information regarding the likelihood of the state of nature is unavailable. These criteria are the criteria of the optimistic person, we can call it optimistic approach, the criteria of the conservative approach, a conservative person, we can call it a conservative approach, the criteria of the opportunity approach, we can call it minimax regret approach. To understand these three criteria or these three approaches, we have to consider together the following numerical example. Consider the following decision problem with three decision alternatives and three state of nature with the following payoff table representing profit. Decision alternative D1, D2, and D3. State of nature or environmental condition S1, S2, and S3. Let us put it in something understandable to you. Assume we are differentiate between renting three sizes of restaurant. A large size restaurant, D1, a medium size restaurant, D2, a small size restaurants, D3. And the state of nature may be fair, good, weak. May be fair, good, bad, S1, S2, S3. If we establish a large size restaurant, D1, and the environmental condition was fair, our profit will be $4 or $4,000. If we establish the large restaurant and the environmental condition or the state of nature is good, our profit will be also $4,000. If the state of nature is poor, we will lose $2,000. This is the meaning of 4 minus 2. If we establish restaurant medium size, under fair state of nature, our profit will be 0. Under good state of nature, our profit will be 3,000. Under poor condition, our profit will be minus 1,000 loss. If we select or establish a small restaurant, our profit under good condition, under fair condition, 1,000. Under good condition, 5,000. Under poor condition, minus 3,000. This is the meaning of this payoff table. By using this payoff table, the optimistic decision maker will make his decision according to optimistic approach. The conservative decision maker will make his decision according to the conservative approach. The opportunity loss condition decision maker, will use the minimax regret approach. Therefore, we have to understand the behavior of each of them by using this example. The optimistic approach. Under the optimistic approach, the decision maker will be an optimistic. So he will select as much profit as he can, or as low cost as he can. The decision maker will select, the optimistic decision maker will select the decision which yield him largest possible profit. Or lowest possible cost. If the payoff table in terms of cost, the decision with the lowest cost would be chosen. Referring to our table, the optimistic decision maker will differentiate for decision alternative number 1 between 4 and minus 2. He is an optimistic person. Which payoff he will select? He will select 4. Maximum, largest profit. With reference to decision alternative number 2, he will differentiate between 0, 3, minus 1, which he will select 3. For decision alternative number 3, he will differentiate between 1, 5, minus 3. He will select 5. By this way, his selection will be as follows. For decision alternative number 1, he will select the payoff 4, maximum payoff. For decision alternative number 2, he will select maximum payoff 3. For decision alternative number 3, he will select maximum payoff 5. Which of these 3 maximum he will select? He is an optimistic. He will select the maximum of them. Therefore, his criteria is max. Because the payoff in terms of profit. But if the payoff in terms of cost, he will select the minimum payoff and select the minimum of them. So he is min max. Min maximum payoff. This is what he will select. So the decision maker in our example, the optimistic decision maker in our example, will select decision alternative number 3 because it gives him maximization of maximum profit. Maximization of maximum profit or minimization of minimum costs. This approach can be expressed in terms of Excel worksheet as follow. Build the following Excel worksheet. Put the numerical example in this area, and then in this column we will select maximum payoff. So our formula will be equal max B5 up to D5. For the next column, equal maximum B6 up to D6. For decision alternative number 3, equal maximum B7 up to D7. Then select the maximum of them. Maximum E7 up E5 up to E7. Then recommended decision if E5 equal E9, A5, decision A number 1. If A6 equal E9, $9 string, the decision alternative A6 D2, the same D3. By putting this equation, these formulas, when we put our figures, our payoff in this area, the result will appear automatically as follow. The best payoff is 5, and the best decision alternative is D3. Just for you to notice. Let us go to the conservative person, conservative approach. The conservative approach would be used by a conservative decision maker. For each decision, the minimum payoff is listed. If profit, and then the decision corresponding to the maximum of this minimum payoff is selected. Hence, the criteria will be minimize possible payoff. Minimize possible payoff is maximized. So this criteria is a maximize minimum maximum profit or minimize maximum cost. Depend on the type of payoff. In the payoff, if the payoff was in terms of cost, the maximum cost would be determined for each decision, and then the decision corresponding to the minimum of this maximum cost is selected. So our criteria is a minimized maximum cost. For the cost, minimized maximum cost. For the profit, maximize minimum profit. Because he is conservative. In our example, a conservative decision maker would use a conservative maximum approach, max-min approach, list the minimum payoff of each decision, choose the decision with the maximum of these minimums. -3, -2, -1, -3, which is the best? -1. So the decision alternative number 2 will be selected. Also, this can be expressed in Excel worksheet as follows. Instead of max in column E, there will be minimum B5 to D5, minimum B6 to D6, minimum B7 to D7, وماكسيمم زي ما هي E5 up to E7, وif to select the appropriate decision alternative letter. The result will be as follows. The maximum of minimum profit -1, decision alternative number 2 will be selected. What about the opportunity loss decision maker or the opportunity regret decision maker? His approach will be called minimax regret approach. In the minimax regret approach, the decision maker will build from the table another table called the regret approach, the regret table. In the minimax regret approach, require construction of regret table or an opportunity loss table. What is the philosophy of this table and how we can construct it? The philosophy of this table or the calculation of this table will be by calculating for each state of nature the difference between each payoff and the largest payoff for that state of nature. Then by using this regret table, the maximum regret of each possible decision is listed as follows. The decision chosen is the one corresponding to the minimum of the maximum regret. For the minimax regret approach, first we have to compute the regret table by subtracting each payoff in the column from the largest payoff in that column. In this example, in the first column, subtract 4, 0, and 1 from 4. The resulting regret table will be as follows. How we calculate this regret table? Let us return back to our original table. This is our original table. What is the largest value in the first column? 4. What's the largest value in the second column? 5. What's the largest value in the third column? -1. To build up, to construct the regret table, we will subtract each column from its largest value. Let us try it with the first column. The first column is A, 4, 0, 1. The largest is 4. So what will be the regret table for this column? 4 minus 4 equal 0. 4 minus 0 equal 4. 4 minus 1 equal 3. Don't forget 0, 4, 3. Second column. What is the largest value? 5. 5 minus 4, 1. 5 minus 3, 2. 5 minus 5, 0. 1, 2, 0. For the third column, largest value -1. -1 minus -2, 1 positive. -1 minus 1, 0. -1 minus 3, 2. يبقى 1, 0, 2. Let us return back to our regret table. This is our regret table. 0, 4, 3, 1, 2, 0, 1, 0, 2. Then, under this approach, we will use this regret table. What is our criteria? Mini-max regret. Minimize maximum regret. So for each decision alternative, we will select first the maximum payoff. For the first row, 1. For the second row, 4. For the third row, 3. So our minimax regret selection 1, 4, 3. Our criteria minimize maximum. This is a maximum regret. We have to minimize it by selecting the regret 1 or 4 or 3, 1. So decision alternative number 1 will be selected. Also, this can be expressed in Excel sheet. But the Excel sheet here is very complicated little bit. Why? Because we will build up a formulas to calculate the opportunity payoff. And then maximize the regret. This is the formulas to get the maximum regret, the regret table, sorry. And this is the criteria, maximum regret, minimize maximum regret, select the recommended decision alternative. This is the result. This is the original payoff table. This is the regret table. This is the maximum regret. And this is the minimize maximum regret. And decision 1 is selected. Now we finished decision making without probabilities. What about decision making with probabilities? What's the difference? When we have information to weight the state of nature to say the probability of occurring state of nature S1, S2, S3 is so and so and so, we will have additional information. In this situation, we will have 3 groups of information or 3 groups of data. The payoff, the decision alternative, the probability of the state of nature. Under probabilities, we will depend on the expected payoff of each decision alternative as follows. So we can call a decision making with probabilities the expected value approach, because we will use the probability to calculate the expected value of each decision alternative. If probabilistic information regarding the state of nature is available, one may use the expected value approach. Here, the expected return for each decision is calculated by summing the product, the result of multiplying each payoff under each state of nature and the probability of the respective state of nature occurring. The decision yielding the best expected return is chosen. This means that we will apply this approach into 3 steps. Step number 1, get the payoff table and the probabilities. Step number 2, calculate the expected value of each decision alternative. Step number 3, select the best expected the decision which yield best expected return. Let us apply this approach by considering the following example. The expected value of decision alternative is the sum of the weighted payoff for the decision alternative. The expected value EV of decision alternative DI is defined as follows. Expected value of DI, expected value of decision alternative number 1, will be the sum of J equal 1 up to N, probability of Sj, state of nature J, multiplied by value payoff of Ij, where N the number of state of nature, B Sj the probability of the state of nature Sj, Vij the payoff corresponding to decision alternative Di, and state of nature Sj. It can be explained more easily by our numerical example. Our numerical example is a Burger Prince example. Burger Prince restaurant is considering opening a new restaurant on Main Street. It has 3 different models, each with different seating capacity. Burger Prince estimates that the average number of customers per hour will be 80 persons, 100 persons, 120 persons. In a certain environmental condition, there will be 80 persons. In a certain state of nature, there will be 80 persons. In a certain another state of nature, 100 persons. A third state of nature, 120 persons. The payoff table of the 3 models is as follows. Model 1, restaurant of Model 1 will yield $10,000 if we are in the state of nature 80 customer per hour. Will yield $15,000 if the state of nature is 100 person per hour. Will yield $14,000 if the state of nature 120 customer per hour. Model B will yield $8,000, $18,000, $12,000 the same. Model C yields $6,000, $16,000, $20,000. We can calculate the expected value of the decision alternative A, B, and C in tabular form as follows. Assuming the state of nature, the probability of S1 0.4, the probability of S2 0.2, the probability of S3 0.4. Notice that the sum of the probabilities is equal 1. How we can apply the approach? By calculating the expected value. What will be the expected value of model A? The expected value of model A is 10,000 times 0.4 plus 15,000 times 0.2 plus 14,000 times 0.4. The result will be 12,600. You can calculate it. The expected value of model B, 8,000 times 0.4, 18,000 plus 18,000 times 0.2 plus 12,000 times 0.4, the sum 11,600. The expected value of model C, 6,000 times 0.4 plus 16,000 times 0.2 plus 1,000 times 0.4, the expected value 14,000. Which of them is the best? 14,000. The best decision model is C, because it yields highest expected value, $14,000. Also, this approach can be expressed in Excel worksheet. This is the Excel worksheet. This is the state of the payoff table and the probabilities. This is the calculation of the expected value. We will select the maximum of each of them, and the recommended decision will be corresponding to this maximum. The output of the spreadsheet. Under this approach, we can calculate what we can call a value of perfect information, or the expected value of perfect information. Under this approach, we have a probabilities. Each state of nature has a certain probability, 0.4, 0.2, 0.4. In our example, 40%, 20%, 40%. Probability of state of nature number 1, 40%. Probability of state of nature number 2, 20%. Probability of state of nature number 3, 40%. But if someone asks us, I can give you perfect information. I can assure to you one of these state of nature will occur with a probability 100%. How much we have to pay for him? This is the meaning of expected value of perfect information, because the perfect information will transmit our decision problem from being with probability to be with 100% occurrence. This is the meaning of the perfect information. Frequently, information is available which can improve the probability estimate for the state of nature. Is a perfect information. The expected value of perfect information is the increase in the expected profit that would result if one knew with certainty which state of nature will happen. If we know exactly a certain state of nature will happen, the expected value of perfect information provides an upper bound on the expected value of any sample or survey information. How we can interpret it numerically? Go to our example. To calculate the expected value of perfect information, first, we will determine the optimal return corresponding to each state of nature, the largest value of each column. Number 2, compute the expected value of this optimal return. Number 3, subtract the expected value of optimal decision, which we determined before, from the amount determined in step number 2. In our previous calculation, we select model C with expected value $14,000. Don't forget it. This is a value and model C. This is the expected value which we got with these probabilities. Under perfect information, the expected value is the upper bound on the expected value. This is what we will calculate it in step number 2. Compute the expected value of this optimal return. of this optimal maximum return. Therefore, we will calculate the expected value of perfect information as follows. What is the largest value of column number 1? 10,000. What is the largest value of column number 2? 18,000. What's the largest value of column number 3? 21,000. This is what we will get by step number 1. Then we will get the upper bound of optimal, the expected value of upper bound, or the upper bound expected value, by multiplying 10,000 times 0.4 plus 18,000 times 0.2 plus 21,000 times 0.4. This is the expected value with perfect information. The result is 16,000. What is our previous best decision? Model C with 14,000. Subtracting the 14,000 from the 16,000 will yield the expected value of perfect information. It will be 2,000. So, when any person asks us, I will give you a perfect information, how much you have to pay for me as a maximum, we can answer him, we can pay for you up to $2,000 only, not more. Because the perfect information will yield additional 2,000 to our current situation. Our current situation, the expected value is 14. With the perfect information, this 14,000 will transfer to be 16. So we got more 2,000. We cannot pay more than this as a value of perfect information. Calculate the expected value of the optimum payoff for each state of nature and subtract the expected value of the optimal decision, 2,000 as we mentioned before. Also, this can be included in a spreadsheet. So our previous spreadsheet can include this to calculate the expected value of perfect information also. Thank you, and let us go to topic 2.